video, we'll review the derivative of a scalar multiple of a function and the derivative of sums and or differences of functions. Using the limit definition of a derivative, we will go ahead and evaluate the derivative with respect to x of b, some constant that's being multiplied by the function f of x. Now b is just some constant that's being multiplied by f of x. So if you are inputting x plus delta x instead of x, that does not affect b. b is just being multiplied still by the front of it. So b times f of x plus delta x minus b times f of x all over delta x, the limit as delta x approaches 0. Now, hey, I have a b in both of these terms in the numerator, so I can factor that out. The limit as delta x approaches 0 of b times f of x plus delta x minus f of x all over delta x. Now b is being multiplied by this entire fraction. So I can take b out of the limit and multiply it by the limit of this entire fraction. So I'll write this as b times the limit of as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And if you notice, that's the definition we started with. So when you take the derivative with respect to x of some constant multiplied by a function with respect to x, then you simply get b times the derivative of the original function. So b times f prime x. That is the constant multiple rule. Let's try some examples. Here we have 2 is a constant being multiplied by the function x cubed. So we're going to take the constant out of the derivative and write it now as 2 times the derivative with respect to x of x cubed. The derivative with respect to x of x cubed, because the derivative of a power function is n times x to the n minus 1. The derivative of 2x cubed is 2 times the derivative of x cubed. 3 is your power, so 3 is n. Pop down, power down. Pop down the 3 to be the coefficient of x, times x to the 3 minus 1 is 2. Multiply your coefficients. 2 times 3 is 6, x squared. And that is the derivative of 2x cubed. Now, some of you may notice that 2x cubed, you could have just popped down 3 times 2 is 6, and then subtract the power and get 6x squared. Yes, you can do that, okay? You can combine the power rule with the constant multiple rule with the sum and difference rules, okay, to help you find the derivative of any function. If it helps you visually, I will rewrite it as 2 over 3 times 1 over x. Now 2 over 3 is a constant that's being multiplied by our function. So take that out of the derivative. This is a constant multiple of the function, or a scalar multiple. Multiply that by the derivative with respect to x of 1 over x. And if you remember, 1 over x is x to the negative 1. We'll rewrite it as x to the negative 1 so that we can use the power rule as a shortcut. 2/3 times pop down, power down. Negative 1 times x to the negative 1 minus 1 is negative 2. Rearrange so that you have positive exponents and only one fraction. Negative 2 over 3x squared. This is the derivative of 2 over 3x. Is there a shortcut for the derivative of a sum or a difference of functions? Let's plug it into the definition. The limit as delta x approaches 0. Anytime you see an input, you will replace it with x plus delta x. So f of x will be written as f of x plus delta x plus g of x. So now we'll replace that with g of x plus delta x. That is subtracting this original sum, f of x plus g of x, all over delta x. Don't forget to distribute this negative. There are some things that are familiar to me. F of x plus delta x minus f of x over delta x, and g of x plus delta x minus g of x all over delta x. That's the limit of f and the limit of g. Rearrange this fraction. F of x plus delta x minus f of x plus g of x plus delta x minus g of x. All of this, or both of these, are over delta x. And if you're taking the limit of a sum, the limit of a sum of functions is just the sum of their limits. So you can write limit as delta x approaches 0 of the first fraction plus the limit as delta x approaches 0 of the second fraction. This right here is the derivative of f with respect to x. So this right here is f prime of x. It's being added to the derivative of the function g of x. So g prime of x. The sum or difference of functions. The derivative with respect to x of f of x plus g of x is simply equal to the derivative of f plus the derivative of g. Very intuitive. Nice. Same with subtraction. This should be f prime of x minus g prime of x. A very convenient rule, the sum and difference of functions. Just know not all rules will be this convenient. Okay, we'll start to get into some that are less intuitive, but that is the derivative of a sum or difference of functions. Let's derive this polynomial right here. Ooh, lots of stuff going on. If you're taking the derivative of a polynomial or a sum or a difference, you can technically take the derivative of each piece separately. Sum, difference of functions. So I'm going to take the derivative with respect to x of x cubed minus the derivative with respect to x of 4x squared plus the derivative with respect to x of 2x minus the derivative with respect to x of 5. You don't have to write all this out. I just want to show you all the steps. The derivative with respect to x of x cubed. Pop down, power down. 3 goes to the front. 3x to the 3 minus 1 is 2. Minus. Okay, 4 is a constant. So you can actually take 4 out of the derivative and multiply it by whatever the derivative of this is. We're going to practice doing it all together. So pop down, power down. 2 times 4 is 8. X to the 2 minus 1 is 1. Okay, same with this one. We have a 2 that can be taken out of the derivative. The derivative of x is just 1, so they'll just do 2 times 1. Minus the derivative of a constant is 0. So the derivative with respect to x of this polynomial ends up being 3x squared minus 8x plus 2. All of that can be done with the power rule, sum and difference, and now constant multiple rule.